And it's time for another Incus release. This is for the monthly release for October. I'm Stefan Greber. I'm the project leader of Linux containers and one of the maintainers of Incus. And this is going to be your look into Incus 6.18. So, what's new in this release? There's quite a lot of very different features in this release. Most of them have been contributed by various community members, so that's always very exciting. And yeah, there should be something for just about everyone in there. All right. The first feature is proper support for systemd credentials. So we already supported some of that by allowing SMBIOS 11 configuration for virtual machines in the past. But now we have proper native support for systemd credentials, both on containers and virtual machines. So you can set either a key value string pair that can then be read easily from within the guest, or you can use the binary format with base64 encoded values to transfer binaries through this mechanism as well. That's particularly useful for any kind of scenario where you need to just pass in data from the host into the guest. That can be used for things like provisioning, that can be used for providing actual secrets like tokens and like in some scenarios. And it's just a very useful mechanism that's directly built into systemd, so usable for basically any of the Linux guests, and saves you from having to integrate through like the Incus guest API or the like to actually pass in data that way. Next up, we've got support for storage volume operations on custom volumes. So that was partly supported with Incus 6.13, which introduced SFTP support for storage volumes. So it was making it possible to mount a storage volume remotely using SFTP. But it did not have all of the other usual functions for creating files, deleting them, editing, pushing and pulling files. That was missing, and now we've added that both in the CLI and the Go client, as well as the kind of legacy REST API as well for those endpoints. I'm saying legacy because these days all of our clients use the SFTP endpoint in the API to do all of their operations. So we don't use the individual REST endpoints for file operations. But we still implemented them here so that anyone who just wants to easily being able to use curl or something to transfer files or do other operations on custom storage volume files, they can do it the same way as is possible with files on the instance itself. Next, we've also added support for exporting an ISO volume back out of Incus. That one was kind of ironic because the way you import or the way you create like an ISO inside of Incus is you import it, but then the export operation was not supported. So that's been fixed now. So it's possible to get back any ISOs that have been uploaded into Incus and then just do whatever you want with the actual file. Next is one that's gonna probably be very exciting for some people and then really not very useful for most others. So if you're using specific BPF programs inside of a container, there is a delegation mechanism that was introduced in the 6.8 Linux kernel, I believe, or 6.9, thereabout, which allows for unprivileged use of some specific BPF capabilities. So specific commands, specific maps, and specific programs. And we now support making that possible by passing through a number of configuration options to just set things up so that you actually get a BPFFS mount inside the container that can then be used to interact with those delegated capabilities. It's not something that I'm particularly familiar with, but something we've had some requests for. So we now have support for that directly in Incus. Next up is pretty exciting, which is the Incus agent can now be built on basically all of the operating systems that most folks care about as far as running inside of a VM. So the Incus agent could already be built on both Linux and Windows, with Windows having only a subset of the features. And now macOS has been added as well to that list. So if you follow one of the guides on getting macOS running on top of Incus, you're now able to actually run the Incus agent in the VM as well, and then use Incus exec, Incus files, and all of those operations, just like you would with a Linux VM. So that's pretty exciting. As usual, like I won't do an actual demo of that because there's always some kind, like the terms of service on the Apple side basically require that you run your macOS VMs on top of macOS hardware, like on top of Mac hardware. So you can just, supposed to run that on like normal Intel or AMD systems. I do have Apple hardware, but only have ARM Apple hardware, and we don't currently have a guide or tooling for running those VMs. So not something I can really demo here. But for those who are using Incus to run macOS, that should be a very welcome change. It also not only does it support file operations and common execution like it does on Windows, but it also supports triggering some of the mounts for 9p shared mounts, and it supports getting quite a bit of details on the running operating system through the Incus API. So that's pretty exciting. Next, we've also added support for VirtIO sound cards now. This is mostly useful for Linux guests because drivers don't exist on Windows, and I don't know if they exist on macOS. But it effectively offers a virtual sound card that's paravirtualized. The guest can use it as a normal sound card, and the sound is redirected over SPICE so that if you have a normal Incus VGA console, you'll get the sound as well. There's actually one restriction there, which is this is not a migratable device. So if you want to be able to live migrate a VM, that device will disappear. Next, we've got a small change to USB devices so that just like we've added for disks a little while back, now USB devices can also be marked as not attached, which effectively allows for just temporarily detaching a USB device and attaching it back later without having to delete the entire device. On the oven side of things, we are now adding support for DNS modes. Not all of the same features that are supported on the bridges, but it does allow turning off the built-in DNS records by setting DNS mode to none. So you basically either have the managed mode, which is Incus, in this case, configures oven to create a DNS record per instance named after it, or turning off that entirely. When you're using a bridge, there's actually an intermediate value, which is dynamic or something like that, where effectively the DNS records get created based on the DHCP queries, but Oven doesn't support that, so we only have none or managed as the options. And then we have another little tweak where you can configure now the MAC address pattern that Incus uses, both globally or at a per project level, to use a different range. Incus at the beginning was using the Zen source range, so that's the 00163E range, and then moved over to the Zabli range, which is the 10666A. But some organizations actually have purchased their own MAC address allocation or prefer to use another vendor's MAC address allocation for some reason. And in those environments, you can actually set your own MAC address pattern. I think in some environments too, they might still use a prefix like the Zabli one, but then use like smaller allocations, so just a limited number of digits within that per server or something like that, in theory, to try and avoid clashes. The reality is that there's like enough bits in half of a MAC address that it's usually not really a problem, but some environments do have some pretty strict requirements on MAC address allocations for some reason. And then the last thing is we've done some more work on the IncusOS CLI that's built into the Incus CLI itself. Effectively making sure that every single API endpoint is now covered by the CLI. And so every single action that can be taken, things like reboot, power off, factory reset, taking a backup, restoring a backup, checking for updates, all that kind of stuff, they all have commands that can be used. And that's it for this release. So now let's go and try to demo as many of those as I can. All right. So getting a local terminal here. And what's first? So first is systemd credentials. Okay. So I'm gonna basically run the same thing as is in the announcement, but gonna be creating a container and a virtual machine, not starting them. This is, I think for the container, we actually have it hot plug, so you can change it live. For the virtual machine, you do need to restart it. So I'm gonna be doing it cold on both in this case, but basically we can do foo equals bar, config set c1, and then v1. Then you can start both of them. The container starts near instantly, so I can check that one first. And then systemd creds, we should be able to do system and do list, for example. You can see if foo is listed as a system credential, and we can do cat foo and we get bar. And then if we do the same on the VM, there we go. We can get it exactly the same way. So that's that mechanism. Obviously, you'll want to pass more variables with more useful content, but that's how the mechanism works in general. All right, I can delete these two, I guess. Next is the storage file operations. So for that, I need a storage volume. Okay. And now I should be able to do create. So the pool I want is default, volume, and hello world.text. So I can create the volume. Can go and edit the volume, edit the file. Can delete it, pull it, all of that. Basically the same way as is possible with files inside of an instance, but this time it's all on the storage volume. And then we can delete the volume itself. There we go. Exporting of ISO volumes. I think I might have actually done a bit, slightly too much cleanup earlier. I don't know if I still have one. I do not. Okay, so that's slightly unfortunate. Let's just pretend we do. So I'm gonna create a 100 megs large foo.iso. And then let's import that. So storage volume import default, call it foo. Foo.iso volume is called foo, and it's an ISO. So I can import that. I can delete this thing, and then storage volume export default foo. And I've got foo.iso again. There we go. Default. The BPF token delegation stuff, I'm not really qualified to demo it, honestly. But we can go look at the documentation a bit for how that's kind of supposed to work. So there's a dedicated page for that, which goes over all of the different configuration options and what they map to as far as what the kernel supports. So we can pass basically any command, any maps, any programs, or any of the attach options that the kernel does support. And when those are set, then you end up with the BPF mount being set in place with all of the right options, and that exposes that to the container. Obviously, it doesn't apply to VMs. VMs can do whatever they want, but this is for unprivileged containers specifically. All right, macOS I also won't be showing because I don't have a macOS VM around here. VirtIO soundcard in VMs. Sure, I don't have a desktop for that one, but we can just start a basic VM and go look at what we see device-wise. We should see an additional VirtIO sound device. I don't know if the basic kernel in Debian 13 actually has a driver for it. I guess we'll see. PCR utils. Okay, so we should be able to see it with that. VGA unclassified multimedia audio controller. There we go. So VirtIO is here, VirtIO sound, and then yeah, we've got a sound card. So if that was a desktop, we could actually play some sound on that, and that would then be carried over Spice. So effectively, if you do a VGA console like that, this would then come up with sound support. I don't know if there's any option or anything that shows the sound channel in here? Don't see anything. But yeah, Spice supports carrying sound, so that would just get sent through that stream. All right. What do we have next? Support for detaching USB devices without removing them. I don't actually know if I've got a USB device that I don't care about that I can pass temporarily without causing any weirdness. So let's see. So that's keyboard mouse, YubiKey. And the YubiKey is the least problematic of the bunch, I think. It's still slightly problematic, but let's try that. So config device add v1 YubiKey USB vendor ID is where is it here? 1050 product ID is 0406. So we should see, yep, USB device was passed in. And now if I edit the device, so I go here, attached false, set that, and we can see it got disconnected. So that's how that works. And then what do we have? We've got the MAC address pattern. Okay, so I can do the same thing as the announcement, basically. So if we create here a container called C1, go look at the MAC address, it's going to be using the, oh, apparently I still have the prefix configured, actually. So that shows it working with a custom prefix, actually. So network, let's go sick. We should see a address pattern. Yeah, so I've got a custom pattern set right now. So if we go and unset that, so bring it back to the default, and then I launch another container. Now this one should have a default MAC. Yep. Okay, so that was kind of reverse from the example I wanted to do, but basically the first container I created got a 00163E and then random address MAC. That's because the network address pattern was set to this template. And then I unset the template, confirmed it was empty, and got back to the default. And as mentioned, this can also be done project set as a config option on a project instead. So we could set the Zen source pattern here. Oops, on my default project here. And now if I launch and go check that, there we go. So you can have both options. That makes it possible in like a multi-tenant environment with multiple projects to make that up to whoever is operating the project instead of the global administrator. So that gives us some flexibility. And the last thing is the IncusOS CLI. So as mentioned, this has changed a bit. I think in the last Incus release, we basically had close to nothing. I think we had debug working and maybe a couple other commands. But now we've got quite a bit more. So if I take a remote IncusOS machine, you can see you can do show to just get a basic output of what the machine is doing. If we go with system, we can do system show, I don't know, storage, for example. There we go. Can list the different topics that can be accessed for the on the system side, and then there's a bunch more things I can do. I can do check, update on that remote laptop, for example. I can also create a backup, restore backup, do factory reset, reset the TPM state if needed. There's a bunch of different options that are possible there, and that's for this at the system level. Then at the service level, we have support for resetting a service if needed. I think only LVM supports it right now, but that's useful in some situations. And then on the application side, we've got also support for backup, restore, restarting an application, doing a factory reset. There's a bunch of options there. On the debug side, also tweaked that command a bit to do proper filtering like systemd style, where you can filter for the unit, for specific boot. There's a bunch more options there, and it also behaves correctly when interacting with a cluster of IncusOS systems now, where it also supports the target option to actually select a specific server within a cluster. And that's it for this release. That's everything that's new in Incus 6.18. Honestly, there's a bit for everyone. There's some VM features, some container features, some features that apply to both, oven features, and some IncusOS stuff. So there's really some pretty exciting stuff, I think, for everyone. We've been spending quite a bit of time on polishing IncusOS now. We're expecting to have like website documentation and everything up later next week, at which point we expect to have a bunch more people try that, which will then include Incus 6.18 and the latest kernel to get like a nice and modern experience for everyone. And yeah, that's it for Incus 6.18. If you've got any questions, feel free to leave them down below, or you can go in our community forum and ask questions there, and I'll see you in the next one. Bye.